Yeah, so let me reiterate. Please, I really appreciate questions. Part of what I'm doing is trying to gather feedback. I want to know what works, but I also, more importantly, want to know what doesn't work or what doesn't exist that you need. I mean, we have an amazing situation these days where we have massive amounts of data, but we also have a major problem. We have massive amounts of data. And so part of what we're trying to do is not only, this is something that's happening, across NASA, across science, trying to consolidate lots of different data repositories into one place, but also make it easier for you to do things like go to someone else's paper and actually figure out how the hell they did what they did, and that if you can actually recreate it. I mean, this is fundamentally the way science should work. You should be able to reproduce what someone has done in order to help you do your own work, but that's a non-trivial thing. What code did they use? What software did they use? What assumptions did they make? But what data did they use? People have processed data and whatnot, and that's oftentimes not available. Most of the time it's not available. But that's something we're trying to change. We're trying to build the kind of infrastructure where all of those things are connected, that not only does the paper have, for example, a DOI, but data itself has a DOI. Software tools have a DOI. That is the direction of basically what's called open science. Okay, that is part of what is open science, to make science reproducible, because that's fundamentally what it's about. So I'm going to focus on the Heliophysics System Observatory. Often it's been called the Great Observatory, but it's more than just all of the missions that we have, but what is the data infrastructure, the analysis infrastructure, and what we're trying to build. So this will be both myself and Tai-Yin Huang from NSF. So she is the director of the geospace section. And so the plan is I'm going to go through the resources that we have and what we're trying to build with NASA. She's going to do the same thing with NSF. And then after that, we'll have a few examples. So it's not really a lab, but it is kind of take a short opportunity to look at some of the things that we're going to show you. So if you haven't, you could download the slides. There will be links within the slides when we get to that point. That my main goal is for you to just maybe go and just kind of mess around and see what's available to get some ideas of the kinds of data, the kind of data resources. And you've also saw, at least with using the notebooks, that you can get a lot of data without having to go to someplace and download data. You can get it physically. However, that's not a perfect thing, because what data do you need in the first place? So you can't just stick it in Python and find out what you need. So part of these resources are places to go to maybe get a quick plot to see the kind of data that you might want, or to even look at an inventory of a spacecraft to find out if this data even exists, or if the observations were made during that particular time. So these are the kinds of tools that you will find in order to make it easier for you to do your science. So the primary infrastructure for NASA is the Heliophysics Data Resource Library, or HDRL. And that's composed of the Solar Dynamics I'm thinking about SDO, the Solar Data Analysis Center, SDAC, the Space Physics Data Facility, the Space Physics Data Facility, but also HelioCloud, which you've all experienced a little bit. And I'll talk about that also in the context of science, of open science. But part of it is you're going to see a lot of features. Okay, you're going to see a lot of resources and whatnot. But the features are not the important part. The most important part is the benefit. I mean, what's in it for you? What's going to help you? I mean, the bells and whistles are great, but that doesn't actually solve your problem. You want to make sure that it's doing what you need. And so part of it is I'm looking for feedback and hoping to find out what are the challenges that you're facing? What are the difficulties you're having in terms of getting the data that you need, doing the analysis that you need? And so if those resources don't exist, or they're not in a form that's useful for you, then what can we do to help you with that? Now, so there's two sort of perspectives of this. There's the domains. What are you observing, whether you're looking at aurora on Jupiter, or you're looking at ionospheres on Mars, or anything in between? What's the data that you need? What resources? What spacecraft do you need to look at? What are the kinds of data products that you need? So that's part of the focus. But then, of course, the other part is what are the missions that provide the data that you need, and do they have the observations that you need for a particular time? So those are kind of the two focuses that we'll have. So in terms of the features, the bells and whistles, I'm going to go through, but all of this information is in the slides, so you don't really need to worry too much about the details. But I'm going to kind of quickly go through what are the things that we are thinking about and trying to provide for you. So one of the things that's important is that we do have data now for 65 plus years for all these different missions. So that's a huge resource to take your problems and go backwards and look at what's available. But in particular, we have also current solar missions through the SDAC, and the SPDF is primarily solar wind, magnetospheric geospace, and then you'll find out more about NSF, which also has especially a lot of the geospace access, and then of course the historical data. And we have a lot of data, so that's one of the challenges. There is so much data, trying to sift through all that. And we're trying to bring the information together in terms of the time, the missions, particular events, and also metadata. Part of the issue is making sure that all of the metadata is in a standard format and that it provides the context for you before you start digging into these petabytes of available information. Some of the different resources that we have different analysis tools. Of course, we have lots of different tools related to Python. I mentioned IDL. Most of you probably don't use IDL. I don't use IDL anymore. But I will say one of the things that is useful, and I had a discussion with people at the Shine meeting not too long ago, you have a lot of advisors, colleagues that still use IDL. And so one of the challenges, and people came to me and said, well, what do I do? Because I don't really want to use IDL. I don't really understand IDL. It's not worth my time, but all the analysis software for this particular area is IDL. And this is especially true for things like SOHO and LASCO, RESI, if you're interested in high energy. What's that? Maven, yeah. So these are some of the challenges. We're actually looking to try to leverage AI to help us develop some tools to actually transcribe and translate IDL into Python. So that's something that came from Shine. We have web interfaces. For example, SPDF has a lot of really great resources that allow you to find out what's available before you start digging into it. There's also Python infrastructure, PySpeedS, for example. Cloud platform, so you've experienced that. So what are some of the advantages of the cloud platform? So the whole idea behind that is that, first of all, not having to download data to your computer all the time, unless it's just sort of looking at initial pieces. You don't really want to let's say you're looking at SDO and you want to do an analysis in detail over a week. So do you really have 10, 12 terabytes to spare? Probably not. So you also now want to be doing some very, very sophisticated and computationally intensive work that includes machine learning, other types of simulations, and most of us don't have the money to buy, if it even exists, a laptop that can do what you want to really do. I mean, honestly, right now is looking, and a laptop that does what I want to do right now was about $9 grand. Okay, so, and it probably will be, you know, not that useful after a couple of years. So instead, let's leverage high-end computing, being able to use GPUs or even TPUs, which Google has, recently developed tensor processors, being able to take your data and bring it to those computational resources without having to worry about that. So that's really the big idea behind the cloud structure. Again, also data standards and metadata. These are minutia and details, but it's still important for you to be able to go through this data and know that you know what you're getting, you know what you need to do with it. And then also lots of visualization and situational awareness. What kind of tools can you use to see what orbits are of spacecraft? Where they are during an event. I'll give you a few examples. I've been thinking still about the May events. Where were the spacecraft? Was Maven, was Mars in view of it? Was Solar Orbiter, Parker Solar Probe, things like that. So being able to have some situational awareness of the resources is important. So these are the kind of tools that we can provide. So also, please don't hesitate. Ask me questions now if you want. My only request is, if you ask a question, try to use a microphone, because I want this to be recorded, because any questions that you bring to me of things that you need, I want to be able to go back and sift through it and make a response to it. So I'm going to put this down here just in case anybody has a question along the way. So I won't go into the details, but we have SunPy. You've experienced SunPy. You've experienced a little bit of Pi-SPAESS. There is a community, if you're not aware, Pi-8C, which also has a summer school. It's every 2 years. They have just done a soft launch of a new search tool for all the Python packages available. Okay, so they're still testing it. They're getting user feedback. I spent some time going through and trying some things out. So that's a really great resource. It should just be pi8c.org, but you can Google it to find out the details. So this is one of the things we want to continue to do. Building up resources of Jupyter notebooks, making sure there's comprehensive documentation. I think at some point we'll probably, if you're familiar with this, build an MCP server that you can actually get some of this information. That's the kind of stuff I'm interested in doing. Okay. This will, of course, all be within GitHub to make it easy for you to just, go to a repo and clone it and so on. One thing I want to mention, I didn't actually put the name, but there are some community support forums. I will make sure that I'm going to provide updated versions of these slides. I'll add some more information, but there's something called Helionauts, which is an online forum for heliophysics researchers and scientists. So check it out, Helionauts. I'll make sure to add it, so don't worry about it, but it'll be in there. Yeah, it's sort of a Reddit. It's actually right, and it's actually built on some of the same. Yeah, it's incredibly useful. And I will say also, I don't know about Pi-SPAESS, but SunPy has a very active developer community, and they're very responsive. So there's lots of good opportunities there. Also, in addition to the cloud infrastructure, there is also some direct software and infrastructure connected to the CCMC, Community Coordinated Modeling Center. being able to use Python to get access to models, do some of the runs on demand and things like that. And this will only get better. These are some of the things that we're working on. So again, this is what I really want you to think about. What are the challenges that you're facing? Okay, what are the roadblocks that you're finding that are making it difficult for you to do what you need to do? So think about that, especially as you're working on your capstone, but just in general for your research. Make note of any of the challenges. I'm going to make sure that you have my email, and please don't hesitate to send that kind of information to me so that we can address it. Because ultimately, we have all these great things, but this is what you really want to be able to get to, okay? I will mention open science. I'm just going to leave, mostly my point is to leave this in here for your information. And I'm actually going to turn these slides into just a document to make it a little bit easier to read. It is important to think about open science, and in particular, what's your workflow and how in doing your research do you fit into this? And part of the reason I bring this up, and this is irrespective of this administration, but open science is a priority, which I think came officially from the previous administration. But the whole idea is, again, it gets down to reproducibility. Okay? And this is actually personally, I think, a big problem in our field. Reproducibility has been much more prevalent in fields like electrical engineering, signal processing. A lot of times when people have developed code, they have a paper, you can go to their code and reproduce everything in their paper. This has been around for years, since I've been in grad school. Mostly it was in MATLAB, but these days that doesn't matter that much. But what are some of the things that are important? The issues that I mentioned, data fragmentation. We have 2 major data repositories, but Planetaries has like a bazillion, okay? Earth Science has a bunch, but they're also just massive. So these are initiatives that are happening across these different disciplines. Being able to go and not only look for information based on missions, but based on regions and what you're trying to do. Another issue that's been a challenge, this is, I think, a bigger challenge in heliophysics because we are formed out of, astrophysics and cosmic ray, geospace, solar physics, different metadata, different formats. And so that's a huge challenge. So there's an international initiative around that, primarily SPAESS, which is developing metadata models to try to make this consistent across all of these different disciplines. This is especially important as we become more and more focused on doing cross-disciplinary work. We're doing science, not solar physics, not geospace. But this is the landscape that we have to deal with in terms of the amount of data, the amount of missions, and it's only going to get bigger. And of course, this is not even including NSF. We have things like DKIST, which has so much data you can't even get it off the island. You have to this is where doing your analysis in the cloud is really going to be important as we get petabytes and petabytes and petabytes of data. And also, as you may do research, let's say you're doing solar physics, but you're really also doing stellar physics, astrophysics missions are going to be bringing in massive amounts of data, which they already have. So to start off, what are the resources for the sun? For looking at the sun from inside out into the outer corona, that's primarily around the Solar Data Analysis Center. There are some particular, of course, you've experienced SunPy. Some of the tools that we have or they're being developed to make it easier for you to do sort of quick look would be, for example, HelioViewer. So has anyone here used HelioViewer? Okay. So if you want to go and look at SDO data really quickly, look at an event, you don't want to download these huge files and process them and whatnot. So the idea was to have something was like Google Maps for solar data for 4K by 4K data, and that was the evolution of HelioViewer. And then within the SDAC is the virtual solar observatory, which is both the web interface as well as the connection through search in Python, for example, to be able to search for data and to download it. It comes from the VSO. So this is HelioViewer for those of you who are not familiar with it. This is, it's a very nice system where you can pull in multiple sets of data. You can overlay data. You can produce screenshots, videos. You can pull in event catalogs to do things like overlay sunspots, flares, and whatnot. There is also an API. So if you want to incorporate and pull these kind of quick look images into your Python or anything, any language that can handle API calls, it uses REST, if you're familiar with RESTful API. Okay. So that's very handy. And there's lots of different things you can do with it. So I think it's really incredibly useful. And the other aspect is it has a very good developer and toolkit access, and you can actually build your own front ends. We even built one for education that was for students that was very simple, didn't have all these bells and whistles to use in a classroom. But that kind of application, you could do a lot with it. Now, as we move out and we think about, so obviously these are, stereo, it both has a solar component, but then there's also things like energetic particles, solar wind. So going to those kind of missions, as well as some of the geospace missions, is all done at SPDF, okay, the Space Physics Data Facility. And they have a lot of really helpful tools to do a lot of the kind of initial look at data to find out what kind of things you need, what spacecraft you want to use. For example, CDAW Web, you can go and find process data, level 2 data, and do quick look plots. So you don't have to worry about calibrations and things like that. So for example, if you're continuing to use the May event, you want to go, well, what happened in different spacecraft on May 10th and May 11th when the geomagnetic storm went from the end of one day into the other one. Same thing, with HelioViewer for solar events. There is also some very useful tools for looking at spacecraft. Yes. Yeah. I don't know so can we differentiate between level 0, level 1, and level 2? So typically, I don't know if this is defined everywhere, but typically level 0 is the raw data. Okay, just coming down from the spacecraft in whatever format. Yeah, bits and bytes. Level 1 is initial calibrations, okay? Responses and all kinds of information about the spacecraft that goes into it. And level 2 is typically a data product. Not always, but it's typically a data product. Like you've actually taken the data, it's calibrated, but you've turned it into distribution functions. You've turned it into a spectrogram or something like that. So that's the standard distinction between them. So if you want to go and quickly look for data to find out if the data that you want is there, you don't want to have to worry about all that. So that's the advantage of using a tool like this. And then the SSC web, as well as there are some interactive tools, a relatively new one called the 4D viewer. So that one can actually do things like look at orbits. And then let's say you're looking in geospace. You want to look at orbits, but where's the magnetosphere? Where are these spacecraft in reference to the magnetosphere? Or let's say you're even doing, heliophysics at the moon. Where was the moon? Was the moon in the magneto's tail? Was it outside? So these type of tools allow you to look at those different orbits, look at the magnetosphere and where it is in response to that. So that gives you basically location and temporal awareness. And then I think that they just made a tool where you can actually download maybe a Java-based or something, the 4D viewer to your desktop. Most of the data is in CDF, so there are a lot of different CDF tools for different languages. OmniWeb is focused on looking at solar wind across different instruments. So handling some of the normalization to bring in multiple instruments like wind and stereo and whatnot if you're looking at the solar wind. This is an example of some of the missions that you can get orbit information from. So you can see that it's pretty extensive. I mean, we're going back to even things like Apollo, Helios. So if you want to do some really, really old analysis. This is just sort of give you an idea of the kinds of information that you can search for. Okay, it's quite extensive. I will personally say it can be a little bit overwhelming, but taking it a step at a time, you can find out about instruments. You can search for individual instruments. You can search for data types, data products, full spacecraft. And you can see that you can even search for, whole classes like CubeSat, balloons, things of that nature. And then you have the ability, when I mentioned sort of quick look plots, you can go in, pick time ranges, and get plots of a lot of these data products to allow you to kind of do your initial survey of what you might need before you start trying to pull data in, into a Jupyter notebook or something like that. And this is where we're going to, work on the idea of going between IDL and Python. You can actually go in and get examples of code. Let's say you want to look at this particular data. Well, what's a general basic template for Python that actually tells you what packages you need installed to do some initial analysis? Okay? And you can do the same thing with IDL should you choose to. But one of the, this is a very useful tool just to give you a starting point. So this is the 4D viewer. This is just kind of what you see when you first go there. This is the kind of information. So there's an example of being able to look at multiple orbits together. And I am going to stop there, and we're going to transition to NSF and let Tyen go through the facilities that NSF has, and then after that, I'll give some examples that we can work through and talk through together. So take it away, Tyen.
Thank you, Alex. Hi, everyone. I'm Tyen Huang. I'm a program director in the geospace cluster in the Division of Atmospheric and Geospace Sciences. So I'd like to thank my NASA colleagues for giving me the opportunity to talk to you about NSF-supported geospace data infrastructure. And this all came about because, we are all part of the interagency heliophysics data group. So when they mentioned that they've been asked to provide, a lecture, regarding NASA data holdings, so then they asked me whether NSF would be interested in being part of it. So I say, why not? So thank you again for having me here. And then, so I guess I will just let you to control the slide, right, Alex?
Yep.
Okay, great. So next slide, please. All right. So regarding NSF, data holdings, I think before I begin, I'd like to mention a few differences between NSF data and also NASA data. Now, NASA data is mostly mission driven, but for NSF data, because we provide awards and grants to principal investigator, which we call PIs. So PIs are the one who produce data, and they're the ones to curate the data and make sure that the data will be available to the public. And so so our data is the data holdings are more like project specific. For example, if that a PI have a project that wants to study air glow or gravity waves, so they would probably have some instrument and collect data, and then they will have the data available. Now, for this smaller scale project, most of the time, PI, they do not have a place to put their data. And so NSF support a data repository for that purpose. And so, on this slide, you will see the module. If you are, doing research in geospace sciences, module is the one that is that should sound very familiar to you, because most of the PIs, when they produce data, module will be the one place to for them to put their data, which we call a data repository. And so what does module do? So module basically, what I'm going to go over, is about what we support, the data infrastructure that we supported. And so module is one of them, and it manages and serves archival and real-time data from a wide range of instruments. Why is it such a wide range of instruments? Because it's coming from from different PIs. So the instruments that the data that they have are such as radars, ultrasound, fluvial satellite instruments, and DMSP, microsync interferometer, LiDARs, images, magnetometer, radiometer, photometers, radiometer, as you can see, VOF and model data. As you can see, module basically, just take every data that PI has and wants to have a place to, to share the data. Module is a place to go. So if you want to, find some data, let's say if you want to find some electron number sensitive data, just go to the site and check out. They have I invite you to click on the web page and just to explore around just to see what it offers, and then have a just play with it. It provides a lot of data. And also, before I move to the next one, I'd like to mention again, because most of the data are contributed by different PIs. So module basically is a collection of data. They do not curate data. And so when you want to use data, when you go to the website, when you download the data, on the disclaimer, it says that please reach out to the PI. Do that. Don't just download the data, copy the data, and then publish the paper without even acknowledgement of the data that you use the data, and also without first control with the PIs, because sometimes there are uncertainties or there are flags that may be in the data. Only the PI will know better the quality of data. So even though with extensive documentation, it would be love for you to reach out to the PI to discuss what all the if there are things that you need to pay attention to. We definitely don't want to publish the paper based on the data that has some as something wrong with it, and you take that as something that is something unusual. So again, public, acknowledgement to their contribution, and also reach out to the PIs if you want to use the data. And the next one on the list is the SuperDARN. SuperDARN is also supported by us, and it provides access to SuperDARN data, which include line of sight velocity, spectral width, path of backscatter signal, and hemispheric neutral rings. And it is in a platform independent net severe file, and also they have data visualization tool that you can use to look at the data, and the links are provided as well. And then we also have MISO, which is for Advanced Modular Incoherent Scalar Radar that provides electron temperatures, plasma line, ion density, collision frequency. So we actually have two radars. One is in Alaska and one is Resolute Bay in Canada. And so they also have data shared with the community. Next slide, please. And the next one is the SuperMag. So SuperMag is is a data repository for magnetic field, and that's coming from the magnetometer. It provides easy access to validated ground magnetic field perturbations in the same coordinate system, identical time resolution, and with a common baseline removal approach. And so it has the global magnetic field observations and products made possible by the contributors. So in other words, if let's say a PI has a magnetometer and collect all this data, what they can do is that they can reach out to the PI of SuperMag and then indicate that they want to share the data. Then the PI of SuperMag there will use the data and then curate the data to make sure that it has the same coordinate system, identical time resolution, and so forth to share the data. So SuperMag is also, if you're interested in magnetic field, magnetic physics study, SuperMag is one of the, data repository that you want to use as well. And the next one is AMPERE, that stands for Active Magnetic Field and Planetary Electrodynamic Response Experiment. It provides AMPERE magnetic perturbation data and data products derived from the Iridium constellation. So for this particular project, what we support is the PI to get the data, they buy data from the Iridium constellation, and then they process the data and curate the data and make the curated data available to our community. And so that's AMPERE. And so I think Alex is going to give examples about SuperDART and also AMPERE later after I finish my presentation. Next slide, please. So in addition to the big projects that I mentioned, NSF also supports some smaller projects that individual PIs. They have smaller data collection, but nonetheless they leave the data available to the community. One of them is called LINSEN, which stands for Low Latitude Ionospheric Sensor Network. It provides GPS, magnetometer, and ultrasound data. I think it's primarily in South America. And then there's a community coordinated modeling center. Of course, the majority funding is from NASA. NSF also, sponsor some of the projects they do by CCMC. And CCMC basically provides access to modern space research models, test and evaluates model support, and also space weather forecaster support, space science, and so forth. And also the next one is called MANGO, Mid-Latitude All-Star Imaging Network for Geospace Observation. So it is a network of all-star manager and public roads to observe wave activities in the atmosphere. And so, if you look at the last figures, you can see that they have several roads and also images of in the circle in those circles that indicate where the instruments are located and the field of view of those instruments. So they also have data available to the community. And for all this data, what we really want the community to do is that we really want them to use the data because, when we spend money, when we invest money, in this scientific project, what we want to do is that in addition to benefit the PIs, we also want that, we want the research product to be available to the community. So that's why, the more people use the data, the better. And also, to hold the data, it does require some investment. If the data is it's just sitting there not being used, then what's the point of collecting data? So I'm so glad, we have this opportunity to let you know what kind of data products that we have. And we do encourage the community to use it to advance science as much as, as possible. Next slide, please. Okay, so in addition to the NSF supported individual PI projects, NSF also support data infrastructure like NCAR. NCAR has a big data infrastructure, service that they do. And so in front of you, you can see there's a data, let me see, geoscience data exchange that provides the public data repository. And there's an information system lab that supports supercomputing analysis and also visualization resources, stores and develops and curate data. So for any PI who has an active NSF award, what you can do is that you can submit a computing time request to NCAR, and then you can use their high, like supercomputing facilities to do your computer work with no expense if you have an active NSF award. And also high altitude observatory, HAO, also provides data from the solar observatory in Hawaii. And also they have public parole and also modeling support as well, that WACA maps. And then CDG provides long-term stewardship for data assets related to geo and helio science model output that are generated as a result of NCAR research. So these are the in-house, done by NCAR. It's just that, if you want to, put the data in using NCAR's facility, you have to submit a request to deposit data at NCAR. And it does come with a fee, if you want to put the data there. And if you want to search and discover data sets from NCAR's data repository, and this is the link is provided here. So the data hosted by NCAR, includes the helio, includes the geospace, and also include atmospheric, science data. Next, please. Right, so the last one I think I'm going to mention is the inefficiency geospace data, geospace data that we supported, and also support data that are used by the solar community and also heliophysics community. And so, for example, DKISS. So DKISS data and also the SOLAS, synoptic optical long-term investigation of the sun, and also GONE, Global Oscillation Network Group. So all this data actually you can just find it through click on the NSF's data link. It does provide the sublinks to all this bullet point stuff here. And also there's a historic archive that has the all the historic data that is being archived at this location. And also virtual solar observatory. And I think this will be my last slide. So maybe you can advance to the next slide to see if this is the last. Yes. All right. So I'll hand it back to you, Alex. Thank you so much.
Okay. So I'm going to go through a few examples, mostly just to put them there. We don't necessarily have to spend too much time on it, but the links are there. And you can go and take, these are just sort of a couple things I picked. I actually went to, yes. Okay, cool. Yeah, and they're most of them are not too hard to find. So I started off, of course, with the NASA. So the first one that I put up was HelioViewer. Again, I think this is a nice kind of situational awareness, for lack of a better way to describe it, of what's happening at the sun. It's a nice tool because you can not only pull in current data from things like SDO, we have LASCO, so you can have an SDO image, have the corresponding LASCO. We actually now have the new NOAA coronagraph. You can add that. There are lots of interesting bits of functionality. There's a timeline down here that you can use. You can actually look at events. You can look at images to see the cadence. So if there are data gaps and things like that, you'll be able to see that. You can pull in information from various sources of things like CMEs that were detected, sunspot region, active regions and whatnot. And then you can go in and start adding layers. pick different time scales. So the examples that I put on here are all from our May 2024 event. This is, as you can see, that's May, well, maybe you can see, May 8th, 146. So that was one of the X flares. One thing also to mention, besides the public API, which is nice because you can then actually pull these images in directly via Python, for example, there is a very nice tool that's made, and I apologize to my ESA friends for not putting it on here, but this is actually a NASA ESA, European Space Agency tool. So they made kind of a branch of HelioViewer that is a Java-based tool, so you can load it on your desktop. So it runs on Windows, Linux, Mac, and they have separate versions for Intel and Apple Silicon. They make additions pretty quickly. The advantage, so HelioViewer is nice because you can pick a time range and make a video. Okay, so that's really not handy. The thing I like about JHelioViewer is it's interactive. So I'm not just picking a time frame and then making an MP4. I'm actually got a video that plays in my screen and I can adjust the time. You can do all kinds of interesting stuff. They have a pretty extensive web page for all the things that you can do, like add annotations and whatnot. I won't even go into all that. So I put this up there. I just encourage everyone to take a look at it, to play around with it. It's very useful. JHelioViewer is also very useful. Whether or not you're doing solar physics, I think you'll find this very helpful. Also, I do a lot of outreach, education outreach. I also do a lot of speaking at NASA to people coming to visit. I use this tool, and especially JHelioViewer, all the time. I actually do a daily blog on space weather, and I use JHelioViewer every day. So, CDAW Web, this has got tons of stuff on it. So I won't go into all the details, but it's just packed full of things. So this is what I was talking about, data products and quick look, okay? So you want to go in and you just want to see if there's an event so that you don't have to waste your time going through, volumes of data to find something. So this is actually got PSP, Parker, solar orbiter, stereo, wind, so you can look at, these are radio bursts. Okay. Lots of different things you can do with this. So, excuse me. Let's see, what else do we have? Also, a couple of things you can do. You can go in and find parameters in some of the data products like TEC. You can look at IBEX. This is actually incredibly useful so you don't waste your time to go through and find out, picking missions and instruments, does the data even exist? So this is really helpful so that you can define your time regions and things like that ahead of time. So I find this really incredibly useful. This is actually really cool, the 4D viewer. Okay, so again, we're starting off, this is during the May time frame. Here you're seeing cluster gold MMS showing you the orbits. You can go in and interactively change your perspectives and whatnot. You can go in and put the magnetopause, bow shock, and see where are the spacecraft in relation to that. You can put the moon in there and put Artemis, for example, to look at what's going on. So this is really, really, really helpful to get some sort of situational awareness for events. Now we go to the NSF tools. I went around and I played with SuperDarn and Ampere. There are a couple other ones, but these were to me the first that I like to play with. So I wanted to add VT. There's a consortium that runs there's older SuperDarn data. The current SuperDarn is run by this consortium that's actually centered at Virginia Tech. So you'll see VT SuperDarn has all the current data. So this is looking at, you can pick Regions, you can pick North Pole or North Polar region. You can pick sort of mid-latitude. You can pick Southern Hemisphere. If you want to look at what's happening, there are sets of different monitors. For example, this is Antarctica McMurdo. Again, this is during the May timeframe, but you can go through and look at a whole bunch simultaneously. So it's very interesting. So I encourage you to take a look at that. This one is super cool. So Ampere. So if you're familiar with the Iridium satellites, you know, remember seeing all the crazy little sparks in the sky? They're very, very bright. So they're using these communication satellites to provide these different data products. And so you can look at winds, currents, things like that. And so I would actually encourage you, this is May 10th at 18 UT. This is right when the geomagnetic storm is kicking in. So take a look at this just before, and then look at this. You can make a video. I originally made these in Google Slides, and Google Slide didn't like my video, so I didn't put the video in. But I made a video during this of the day before through the geomagnetic storm. It's pretty freaking cool. So you can pick these different data sets, or you can do kind of a look at all of them together. So this one is definitely worth taking a look at. So there's lots of good stuff here, and we'll make sure to have all this. Again, I'm going to take the slides. There's some additional information I want to add. And honestly, whatever feedback I get from you all, if it's things that I actually can answer now and provide some feedback, I will put them in these slides, because I'm going to turn the slides into a document to make it a little bit easier to go through. But what I really want to encourage you is, please don't hesitate. This is part of what I do, part of what I'm interested in. I've got up here, I never go without swag. Unfortunately, I don't have as much swag as I would like. These are, you know, it's got a little space on your laptop. These are HGRL stickers, so help yourself. You don't have to take one, but I have cards if you want to take them. There should be, I have 28 people, right? So there should be like 30 here. So I'm going to put these here. So when we take a break, please help yourself. But part of what we're trying to do is not only consolidate all of these resources across NASA, across NSF, but we have lots of tools that we're continuing to add. So one of the things that I didn't put on here, because we've only done a soft launch, is, you know, part of the long-term goal is to not have SDAC and SPDF, but to simply have Helio data. So Earth Science is doing the same thing. Other science divisions are doing the same thing. So we have Helio data right now. It's helio.data.nasa.gov. Please feel free to go there. It is a work in progress. But saying that, I got some fantastic feedback from Shine. And if anyone is interested in giving me feedback, sitting down at a table and doing it in person, doing it over a Zoom chat, or just play with it and then write me and say, this is great, this sucks, whatever. You know, the more feedback I get, actually the negative feedback is more useful than the positive feedback. So especially if things don't work, doesn't make sense, or if there are features that you want to add. So that's kind of our long-term goal. Because eventually we're going to have a lot of this infrastructure to bring all of this together. And that's where we're going. We're working closely with NSF. We're putting a lot of the data on Helio Cloud. So for example, right now we have, I think it's 2 to 3 petabytes of SDO data on Helio Cloud. We have a huge amount of MMS data now in Helio Cloud. We have started adding, I believe, some SuperMag data, and we'll continue to put other data sets on there. So eventually, it's all going to be there, and you can take your computing, take it to the data, and do what you need to do. So there's lots of stuff here. I could go on for a long time, and I'll be around So let me stop here and first say, because I don't want to keep Tyen on any longer, but do you have any specific questions for NSF related data products, data repositories, anything like that? Yes.
Probably a bit of a depressing question, but are all of these kind of systems and services safe at the moment from current administration? Like, is there any risk that these will no longer be supported, or are these kind of good, like they're protected?
Not as far as I know. That is a good question, and unfortunately, it's an important question. I want to be very careful, especially being a civil servant. I have to make sure I don't stick my foot in my mouth. But right now, all the impression is, despite what has been directed towards science, heliophysics is in a very good place. Especially, obviously our science is very important, and the science for the sake of science is very important. However, all of it has an application to space weather, to national security, to all of these areas, and that's an important saving grace for what we're doing. So I think the data is still considered very critical, and I think most of us will fight tooth and nail to make sure that the data is still around and nothing happens to it. And part of what we're trying to do is also go back and still take as much older data and make sure that it's in places like the cloud, so it's not going to go away. Yes.
Are all the data mentioned today publicly available, or
Yes.
some of them are restricted?
Nothing here is restricted. So I don't know specifically, I can't speak for NSF, but for NASA, it is all open. So, I mean, but both NASA and NSF, I mean, we are public agencies, and so therefore the money that is paid by the public to support it means that it is your data. Yes.
For DKIST, are you thinking about making the raw data available, like really the image bursts?
That is a really good question. I don't know exactly what DKIST is planning to do. I will certainly find out, but we'll have to talk to the NSO folks. I have to maybe go talk to Holly upstairs about this. But I hope so, but I'm not certain. But that's a very good question, and I will find out. Yeah, Tyen, do you have any comments about that?
I don't know the answer to that because I think the hurdle to showing the raw data coming because it's a big size data, the data just the size of data is too huge. I would talk to the engineers and then see, and also the whoever's in charge of this just to see whether there's a plan to do that. If there's a willingness to do that, then what is the timeline? And if I have more information, I'll definitely I'll let you guys know.
Yeah, so let me follow up to that. One of the things that I think is important is, while there's of course no guarantee that anything you need or want is going to be available for financial reasons or whatever, the most important thing is that you ask. Because being in the middle of it, it's so hard to see what everyone else needs. And so that's why your input as you do your research is absolutely critical. And if there are things that are important, do not hesitate to reach out to me, to reach out to appropriate people at NSF. You can even reach out to me and I can help you talk to the right people at NSF because we're all talking to each other. But it's important for us to know, because if it is important to the community and there is something we can do about it, we will do our best to address that. Absolutely. Yes.
And I just want to follow up on Christoph's question, just because, like, what do you mean by raw data? Because you talked about level 0, level 1, level 2. Like level 2 data, if any of you are starting to look at like, none of you are looking at level 0 data. Right. Nobody wants to be looking, 101110. But I imagine, so probably most of you are going to be looking at level 2 data. So I imagine that DKIST and other facilities like SuperDarn also have the data pipeline that turns like voltages into science data, right? Into wind velocities, or in the case of DKIST, a nice image. So so I guess what levels of data are available from, say, DKIST that and I don't know if Tyen has that wants to respond to that.
You know, because I don't, personally deal with the DKIST data, so I really don't know. But I think you can find the information on the web on the web page, which is to see what sort of data they provide. But because again, the size of data is just humongous that they actually share data at the they don't share all the data. So sometimes if you want to, for your particular research, if you want some data, it would be best to reach out to them just to see if they can make them available to you. But I think the data, they're supposed to share the data with the public, but I just don't know to what extent, they probably won't be able to share all the data. Only the one that I think will be available, will be most useful to a science community. So I don't know who asked that question, but I don't know the answer. Sorry about that. But you can definitely reach out to Terry Black. She's the program director that handles the DKIST. She will have the information. Sorry about that.
And so some of the things to remember is if you're going to, if you have a need for something, also try to be very specific in what you're saying, as opposed to just saying, is this level blah going to be available? What is it exactly that you're trying to do? Because there may be something that they have that they could, meet your needs. The other thing to remember also, and this will vary from every instrument, some instruments will keep their level 0 data because they recognize that their calibrations will change drastically over time. So for example, SDO, as it, and this is the same for any EUV instrument, as the filters and the grid start to degrade over time, they'll go back and update calibrations. Some instruments may not do that because the data is just too big, especially if it's a spacecraft and they only can get so much down. So it really kind of depends, but if it's data that's scientifically valuable, and if it's not obvious in their data pipeline, then, I think in most cases they will accommodate you.
I mean, they provide like these data products from other telescopes. For example, Gregor, they have like this dark and flat field corrected observations where they provide this image bursts. I mean, they are huge, of course, but yeah, I think it could be very helpful to have this data too, especially for me.
Okay, yeah, so it's definitely worth asking, and I'm happy to help you follow up with that. So I know the program scientists, Carrie Black, very well. So I'm happy to both be an intermediary or help you contact people directly. So.
Working? Okay. So the thing that'd be really useful for me is like planetary specific stuff, so Mars in particular. And I know that like ISWA has the Mars page now, but thinking like forward for future missions, I mean, ideally we would have the exact same products that you've got for Mars and other planets, but obviously that's not feasible with the current missions. But like for Mercury, is there plans to use like Bepi Colombo data, and then for Mars, like Escapade? Like, is that kind of, particularly thinking of like Moon to Mars and stuff, is that something that you guys are like thinking of working on?
Oh, absolutely. Yeah, absolutely. I mean, there is an active program, and with Moon to Mars, I'm working on aspects of it. So we're actively thinking about all the aspects of data, even working out, communication relays and infrastructure for all of that. So yeah, absolutely. So and also There's fortunately, a lot more crossover between, let's say, heliophysics and planetary for that very conversation, to make sure that we're all on the same page. We're not, right now there's also a good conversation between the Mars atmospheric modelers and Earth Science with their models, because ultimately the plan for going to Mars is we need to know what's happening on the surface, and what's happening on the surface at Mars because of its environment is directly connected to heliophysics, which is not the case, let's say, on Earth. I mean, you've probably seen the images. We see particles hitting the mass cams. We saw that after the May storms, that active region went around. Solar orbiter saw a very large X flare, and the planet was blasted with some of the strongest radiation we've seen, and you can see it on the cameras. So what's happening on the ground there connects all of those areas. So yes. Yes and no. Yes, in general, that is what we're striving for. And I would say, and I had a conversation at Shine about this, the scientists who work on these different missions very much want you to reach out to them to talk about. They really, what's frustrating to them is when people take their data and do some sort of research and haven't looked at, the data documentation for their instrument or their mission, because people tend to make assumptions and find things in the data that aren't there. So that kind of information is available when you go to these various data sources. Within there are metadata. There is usually links to the papers, the initial papers that came out for the mission, for the instrument, as well as documentation from the scientists and engineers.
And two quick things about that. Just because they don't respond to your first email doesn't mean they don't want to talk to you.
Yes.
Right. So, my trick is I go back to a week later, I go back to my sent folder and say, hi, I'm, just checking in to see if you had a chance to think about this.
Right. Right.
And
putting this back in your inbox or something like that.
Right, and then the second thing is, could you just say just a little bit more about, I'm not sure everybody's aware of what metadata is.
Okay. So I mean, if you're not aware, so metadata is all of the contextual data. You've got the raw counts that came out of the instrument. The metadata tells you when this was taken, where this was taken, what instrument this was taken, all of the circumstances around that particular measurement. And part of the goal across all of these different areas is to make sure that those formats are consistent, are uniform, so that what's in the header of a file from SDO has similar kinds of information as to what's in a header from MMS, even if they're vastly different instruments. Because typically metadata has a keyword that says, the time, and then this is the time. And believe it or not, it's very difficult because people use different keywords for the exact same thing across missions, and it's incredibly frustrating. So metadata is very important, and it's all of the contextual data that tells you the details of what's going on, including calibration information, for example. I wanted to follow up with what Nick said. Absolutely, and maybe this is not an issue for many of you, but don't ever take it personally when you don't get a response from somebody by email. And I know you all understand this. We are so overwhelmed with email. Right now, we are trying to do things like use AI and other tools to help us process the fact that, for me personally, I get hundreds of emails a day. I get you know, Teams messages, I get Slack messages, I get, you know, just go on and on and on. And it is so overwhelming. And for me, I am neurodivergent. I know that we are all overwhelmed, but I just like, it just drives, you know, it's completely shuts you down sometimes. So don't ever take it personally. People are incredibly busy. You all are incredibly busy. And so, and if you have trouble, if you try to get to somebody a couple of times and you don't hear from them, find somebody else, because there could be a lot of reasons. The person could be on vacation. The person could have had a family event or something like that. So just sort of keep that in mind, because we're all overloaded. It's really tough.
There are some contact people for some of the. They're not with us anymore.
Yeah, yeah. And that's important too. You know, we're trying to bring all this together into a uniform place to address that. But just like going to a place and you find dead links, I don't want to use, I shouldn't have used the word dead, but you go and you find contact information and they're just not with us anymore. Okay, so again, it's just information overload, and it's really hard to keep up with all that. So don't hesitate to reach out to somebody else, and you know, it's fine. Certainly don't ever worry about, for me, because this is part of what I do, send me a note and say, hey, you know, this email bounced back or blah, blah, blah. The other thing is, if you are in a certain organization, whether it be government or not, a lot of times, of course, your emails are cut off. So somebody may move to another organization, the email is not changed, and so email will come back to you. Yeah, but any of that kind of information is useful, and it helps us. But yeah, you will find sometimes people just are not around anymore, unfortunately. So, are there any other specific questions?
Last questions.
Any last wish? Yeah. Hold on to that. Don't forget. Okay.
Is like in a conference now. So for the neutron monitor data, is it included in the cloud or?
You know, I think there is some neutron monitor data, but I mean, it's typically not part of the infrastructure. However, you know, there is some with NSF, but you know, most of it, of course, is ground data. So, but we're certainly trying to change that. I mean, I use neutron monitor data, so I think it may be something that we would like to add to Helio data, but at the moment it is not included directly. Yeah. So
Right,
you have to go to the network. But do you have anything to say about that for?
Right, so we do support neutral monitor. We do have a project that, you know, that collect the provide the neutral monitor data, but I did not include in the slide. I will find out more information and I can add it to you. You know, I will give it to Alex so you can put in, you know, since you're going to revise the slide, the updated slide. So I will find that information and I'll give it to you. But we do, NSF does support project that provides neutral monitor data to the community.
Anything else for Tyen? Okay, go ahead.
Okay. I wanted to jump off of what you guys were talking about a second ago with points of contact being, you know, deceased or dead to us. And I know as an early career, or even if you're just trying to implement like data from a new mission you're not familiar with, finding this information can be really difficult for points of contact. I was wondering if for NSF and for your guys' data, if there's maybe plans to keep kind of a point of contact sort of bundle of information, or even like home institutions kind of nestled with the data to kind of make it a little easier to find. I know that's not the easiest because you'd have to update it, but it would make it easy to.
Actually, yes. So it's something that I'm working on. I will say this has actually been the kind of thing that I've found AI is going to be very useful for, is putting together those kind of resources. So, I mean, for what we're doing, NSF is a collaborator, other people are collaborators. So we are trying to build that information as we're bringing it all together. So ultimately, yes. Have we specifically thought about it in terms of a contact resource? I don't think so. However, I think that's a great idea. So you are now recorded. And so that will go into the to-do list.
Great,
So
thank you.
I will make sure, because one of the things we're also trying to do using some of these tools is to also kind of related to that is developing networks to better collaborate. Okay. Right now, for example, if you want to go to Goddard and you want to pick any of the science groups, whether it be Helio or Planetary or whatever, the last thing you want to do to try to find somebody to collaborate with is to go through and look at every person in their CV. I mean, that's absurd, So, but we have all that data. It sits in databases in the back end of websites. So we're now using, knowledge graphs and things like that to start making those connections. And that should be a clear part of it because the missions are connected to that. The instruments are connected to that. So
Yeah, and the last thing you want to do is go through like a 20-year-old instrument paper and try to find people.
Absolutely, of course. So the technology does exist, and we are trying to build those collaboration networks, and that would be a natural part of it. But I can make sure that is called out as one of the outputs that you can get from that. So that's a great. I'm glad you brought that up.
Thank you.
Mm-hmm. Mm-hmm.
Looking for not this person, but this
Right.
somebody with knowledge about, like you were talking about Apollo data. Good luck finding the original
Right.
instrument people for the Apollo data, but somebody who's got expertise in that.
Yeah. Yeah, I mean, you have to sign up, but you just have to give an email, typical thing. But it's very active. I definitely recommend. I mean, I struggle again because it's just one more channel I have to turn to. However, it is pretty active, and there are things you can do to kind of tell it where, what kind of information you want to get from it. So I think that's really useful. We're just in terms of thinking about information, part of the overall goal of HDRL and just science in general is to not just think about the data just in terms of the science data, but the knowledge data. So that is part of it. So the idea is to connect not only the papers, but the people that write them, their contacts, what they do, all of that. We have all that information now, and we have the tools to start making those connections. So ultimately, going to the resources will be a place to not just get the data itself, but that metadata, which is all that other information, is all going to be part of it. Now, we got a ways to go. It's a lot to do. Personally, I'm working with a colleague, Barbara Thompson, who's now the head of SDO. We're building these kinds of tools internally, but building them internally is really ultimately for the community. We're testing them internally, but things like newsletters. Okay, I mean, there's the Shine newsletter, there's the CDAR and GEM, there's SPA, there's Solar News, on and on and on and on. So we're just trying to figure out right now about making a little tool just to consolidate all those newsletters and then just have it in one place. I mean, I don't really want to get 10 emails and have to go through all of them. So those are the kinds of things we're trying to think about to take away from all that mundane stuff that we have to do so that you actually spend your time doing your science. I mean, that's the ultimate goal. So anything that we can do to help facilitate that is absolutely will do. And I appreciate that that suggestion, because I think that bringing the contact information into that is going to be really helpful.
I want to call for last questions for tie-in so that we can, if there aren't any last questions, NSF side.
Okay. Yes, thank you, Tyann.
Great, thank you so much. So again, I encourage you to look, to play with those website and use the data. Which they are available. The more that you use, the better. Leading more discovery in science. And thank you so much to Nick and also Alex. So I'm going to log on because I've been receiving calls. So yeah. Okay, bye.
Bye. Thank you.
And sort of move into our general Q&A. I have we asked a lot of questions already. I've advanced lunch but if you need, let's go into the general Q&A. More questions for Alex. Any questions for Prasad here?
I have a question for Alex. I have a question about, for example, if we have a specific mission like Helios, have the data set of the velocity distribution function. I know that there are many efforts to deal with these velocity distribution functions to calculate the moments. So do you or will you try to collect all these data sets and archive them, or what should I expect?
So, well, let me make sure I understand. So do you mean that this data exists, but it's not necessarily in the like SPDF?
Yes.
Okay. So is this data a product that you are calculating or colleagues are calculating in research?
Yes.
Okay. The long-term answer is yes. I mean, one of the things that's been asked to me is kind of related to that, but a lot of people have come and said, okay, well, we have a ROSES proposal, and we're required to write a data plan and keep this data from our research, but how do we do that? I mean, do I have to buy servers and keep this, and what if I move to another institution, and so on and so forth? So part of the plan moving forward is to, if it's supported research, to have the ability to have data sets that are within the infrastructure. Because people should be able to also go and find what you wrote a paper on and be able to reproduce it. So for your specific example, let's talk offline. Reach out to me, and I can talk to the people that I work with and get your specific situation and work with you to see what we can do. So I can't answer you specifically, but just know that this has been an ongoing question that people have asked about, we're supposed to do this, but how do we do this? It's not really included in funding and things like that. So that should be part of what we do. And so let's definitely, we can talk about that. Yeah. Yeah, lunch today, or also grab a card, or just make sure you get the email, send me a note, and we will, I will find the appropriate people if I can't answer it, and we'll work with you on it. So stickers are up here, cards if you want them. Don't hesitate to send me questions. Does anyone have any more questions for Farzad? If I didn't have to talk, I'd let you go on because I love the stuff that Farzad does. So.
All right, let's break for lunch and back by 1:30.
So thanks everybody, and thanks for the questions. Some really great questions. I'm glad that this is recorded. I'm going to make sure to follow up on any of those. And at any point in your research or your work, if there are other questions related to this, please don't hesitate, because ultimately this is a service. We're trying to serve the community, and we want to make sure that we can do that. So.